really big here, but I'm going to highlight this. So if you introduce the square root, we put the plus and minus, right? So what I want to show you is the plus part of the square root is like the top half of this. It's a sideways, it's literally like a sideways parabola. So it's like a sideways, just in general, it's a sideways U shape. But I want to distinguish the two parts. One part makes up the top, one part makes up the bottom. So just y equals just a square root of x. That is the top half of that sideways U shape. And then the minus that you've got with the plus minus is the bottom half of this sideways U shape. So that part of the graph is y equals just like a little negative out in front of the square root. Okay, now if you guys remember, we haven't talked about functions for a second, but if you have a function, no x value can repeat. So also it has to pass the vertical line test. You guys can see like this fails the vertical line test like literally everywhere on this graph except for 0, 0. So like my x value 4 has two different y coordinates. One of them's 2, one of them's -2. 9 has two different y coordinates. One's 3 and one's -3. I picked x values that would be perfect square roots so we would have nice points on the graph. But you can take the square root, any of these positive numbers. It's just not going to be a nice value unless your x is a perfect square. Now the deal with what we're going to graph, we are going to graph these as functions. So basically to curb and get it so it'll pass the vertical line test, you are either going to be graphing the top half of the sideways U, that's if it's positive, or you are going to be graphing the bottom half of the sideways U, so it would be just negative, and then it'll pass the vertical line test. So I just literally copied what was above, but I only graphed just a plain square root of x. It doesn't have a negative in front of it. So it would just be the points that you see here and all the points in between. I just chose the x values to use perfect squares so we would have nice points on the graph here. But literally, if I just plug these in, like if I take the square root of 0, that's 0. That's actually where the graph starts, right at the origin. If you plug in 1, square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. And just on down, I went up to 7 here. So those are the points that you see marked on that graph there. And then that's a function. This passes the vertical line test. Every x only has one y. No problems here. So this is just the top half of that sideways U. So if you just have a square root, nothing in front of it, it's going to look like that. Now, if you have a negative, this is the bottom part of that sideways U shape. Basically what happens here is you would take the square root of the x value, but then every single one of them would get multiplied by a -1. The coordinates are going to be just what we wrote down. This one also starts at 0, 0. If I take the square root of 0, that's 0, multiply that by -1, that's not going to do anything. If I take the square root of 1, that's 1, but then with this little negative out in front, all that does is it turns that negative. So you take the square root of 4, that's 2, but then you're multiplying it by -1, and it gives you this shape. It's the bottom half of this, it's like a sideways parabola is what it is. So these guys are just the same numbers, just with a negative in front of them, because you're going to multiply each one by -1. So those are the what we call the parent functions, the most basic version of a square root and a negative square root, so you guys can see those. Is anybody having a question? Okay, now I'm going to show you the cube root on the back. Cube root is a function. You don't have to restrict it because, oh my goodness, I can't, what did I just do? You cannot, or you can, hang on a second, there we go. These are both the cube root. All right, so you can take the cube root of a negative number, right? If you guys remember that. If I have an odd root, I can do that for a negative number. So instead of being like a sideways U shape, basically what happens with the cube root, don't draw this on your paper. If this were to go like a sideways U, because I can take a cube root of a negative, it takes this half and flips it to go backwards because I can actually take the cube root of a negative number. So you got like kind of the sideways top part of the U and then backwards sideways top part of, or bottom part of the U, but it's flipped the other direction. If you actually put in your lovely numbers here, like if I take the cube root, and I pick nice numbers, of negative 64. So cube root negative 64 is negative 4. And you'll see that way down here. I have these points kind of marked on the graph so you guys can see the general shape here. But I can take the cube root of every number I've got in this table. Negative 27 would be negative 3. Negative 8 would be negative 2. Negative 1 would be negative 1. Now 0 is 0, and that's directly in the middle. That point is where you're going to flip from one side of the graph to the other. It kind of looks kind of like an S a little bit. Now the rest of these, if I take the cube root of a positive number, then it's just going to be a positive number. So just be 1, 2, 3, 4. I only went up to 4 just to kind of give you guys a general shape of the graph. So if you have a positive, there's nothing in front of it, just a cube root of x, the general shape, you'll have this like middle point, and be kind of like the top half of a sideways U. Because if I take the square root of a positive, that's a positive number. So all these are positive, right? If I take the square root of a negative number, that's negative. So then those y values flip backwards and go negative. So that's the general shape. You guys will not have to plot specific points when we actually put these on the graph other than the very middle. If you put a negative in front of this, what it does is it flips. I'm going to show you kind of both at once. If you have a negative in front of your operation, which I do here, I'm going to write this down. What that does is it reflects your graph over the x-axis. That's true for any type of a function. If you have a negative out in front of your operation, it's going to take your original graph like we just looked at, and it flips over the x-axis. So like if I'm looking at this one, this top half here goes like this, right? If I were to take that and flip that over the x-axis, that gives me this piece on the graph where I have a negative in front of the cube root. So I'm literally just taking this, just flip it over the x-axis. Kind of the same thing if I do this one, right? If I flip this over the x-axis, that would actually flip it up, and so it goes here. And then you got that point in the middle where they switch directions. So they're flipped over from each other. Now the deal with this, you can always take the cube root of a negative number, and what happens in this situation, you're going to have the cube root of a negative number, but then I'm going to multiply it by negative 1. So it'd be like a negative times a negative. This is positive 4. So that's going to flip it. So when I take the cube root of a negative here, because this little negative 1 out in front, all those y values end up being positive. So like this would be positive 3, positive 2, positive 1. 0 is going to be right in the middle, and that's just going to be 0. What goes on if you take the cube root of a positive number now? You've got this little negative 1 out in front. So cube root of 1 is 1, but then I would multiply it by a little negative. So now, if I'm going to the right, bless you, all these guys are going to be negative y values. Because I'm going to take the cube root of a positive number, which would be positive, but then we're going to multiply it by a little negative 1, so it flips it down, and then all the x values going to the right there are going to be negative. All right, so the general shape, then, if you have a cube root that's got a little negative in front of it, the general shape is going to look like that. Is anybody having a question? Okay, now we're actually going to shift these. These are the parent functions, so the most basic version, and I'm going to have you guys actually shift these around today. So I just put another copy just so you can see it of the graphs, and the reason I put a little parabola up there, x squared, the square root and the squared, those guys are inverses of each other. So the squared is just like a parabola like you guys have seen. Square root is the inverse of that. That flips it over the line y equals x. And then remember, we just restrict these so we can make them a function. So it's not both sides, the top and bottom half of the sideways u. It's just one or the other. So just a plain square root or a negative in front of the square root. This is the top half. If you got a negative, it's the bottom half of that sideways u. Okay, I'm going to all the way go over here to where it says diagonal translation, and I'm going to write this in. So I'm going to write y equals, all right, and under a square root, I'm going to write x minus h, and that minus h is under the square root. And then outside the square root, I'm going to put plus k. That diagonal translation is going to be a vertical translation and a horizontal translation within the same equation. So vertical translation, I'm going to come back over here, is going to be affected by the k. So if you see the k over there, that vertical translation is going to move the graph either up or down. And I'm just going to make up a number. Let's say I had my k value was plus 5, then this would go up 5. If I had a minus 5, then it would go down 5. So whatever's outside that square root operation, it's going to go exactly the way you think, up or down. Now, the one in the middle with the x, the h there, h is going to affect how the graph moves left or right. And this one's always tricky. It's the opposite way that you think. So whatever h looks like to me it's subtracted there, so it would look like a negative. It actually goes the opposite direction. So like if I had under my square root, let's say we had, I don't know, I'm making something up. Let's say we had x minus 7. This actually goes to the right 7 units. It's the opposite. So it would be positive 7 would be the x coordinate I would use for where I'm going to start that. It's the opposite of what it looks like. And it's because it's where it sets it equal to 0 is where you're going to start these graphs. So if I had like, I don't know, I'm making something up. So if I had x plus 8, to me that looks like a positive 8. But in the actual formula, it'd be minus a negative to result in having a plus sign there. So this would actually go left 8 units. So inside with the x is going to affect the x coordinate of where you start, and it's going to be the opposite way that you think. Whatever is outside, that's going to be the y coordinate of where you start the point, and it goes up or down, and it'll just be whatever that number. You're going to copy it. So the actual starting place would be HK. That'd be where you would start your square root. And like I said, whatever the h is, it's the opposite of what it looks like. And whatever the k value is, you're just going to copy that number. So we're going to just translate some of these graphs here today and then do the domain and range real quick. So, all right, I got square root of x plus 3. If I just have a square root, you just got to give me the first point and then just a general shape. If I just have a plain square root of x, I automatically know that should be the top half of that sideways u. I don't have anything making it negative. I just got to figure out where to put it. What would be the x coordinate of where I'm going to start this? What do you think? 0. There's nothing inside with the x, so we're not moving left or right. Outside affects up or down, so we're just going to go with 3. So from that parent function, just square root of x, what we're going to do, we're just going to shift everybody up 3 spots. That's all this is. So instead of starting at 0, 0, we're going to start at 0, 3. And again, I don't need, other than that first point, I don't need specific points. I just want to see like a general shape. Just kind of try and draw a sideways half of a U shape. And they should not ever point to the left. They should always, if you're working with a square root, point to the right. You guys will do stuff where it might flip over in pre-calc, but for our class, we're always going to go to the right if we've got a square root. All right, now, domain and range. What's the first x value I touch on that graph? 0, yep. Okay, now you actually touch the point, so I'm going to use a bracket, 0. And then it just has a little arrow, goes to the right forever and ever and ever. So the x values from 0 would get covered all the way up to positive infinity if we had a bigger window so we could see more of the graph. Okay, now for the range, I'm going to go from the bottom to the top and we're going to talk about y values. What's the first y value I'd touch on that graph? 3. All right, also we're touching that point, so I'm going to use a bracket. Now, I know this, it looks kind of almost like it levels out. It does not. It does continue to go up forever. It just goes very gradually. So once you start at the 3, you would cover every y. it would just go really slow, but it would eventually go up forever. So this actually also goes to infinity. Does anybody have a question? Whatever you do for square root, the domain will be the x-coordinate of the point where you started it and go to infinity. The range is going to depend on whether it's a positive square root or a negative. If it's a positive square root, it should just be the y-coordinate to positive infinity. Okay, let's try this one. So I got nothing inside with the x, so we're not going left or right, and I got a -2. So 0, -2 is going to be where I start this. Nothing out in front making it negative, so we're just going to do a little top half sideways u, done. Domain, it should just be bracket x-coordinate to infinity. And the infinity symbols always have parentheses, right? Because it's not a specific point that we touch. That's why it doesn't have a bracket. And then our range, you don't touch any part of the graph until you get to that first point we drew. And that's -2 for the range for the y value. And then again, it looks like it levels out, but it does go up forever. So it's going to go up to positive infinity. All right, who can raise your hand and tell me, where would you start under the square root x plus 4? Where would that start? What point? Yeah. -4 what? On the x-axis, yes. Okay, so whatever it looks like on the inside, it's what sets it equal to 0, so it's actually -4. There's nothing being added or subtracted to that square root, so it's not going to shift the graph up or down. It's just going to shift it to the left 4 units. So just start at -4, 0, and then you're just going to draw, that's a positive square root, so there's the top half of that sideways u. Okay, now just, I don't know why, but sometimes when the point's on the x-axis, people get tripped up when they do the domain and range. So first x value I touch is -4, and it goes to positive infinity. What is the first y value you touch? 0. I don't know. I think it's because it's on the axis and you can see the number that trips people up. But the first y value I touch is actually just 0, and then that goes to infinity. Okay, those were each a single translation. Like this is just going left, or this is going up, this is going down, this is going left. The rest of these are going to kind of do two things at once. So these are diagonal translations here. So I've got number 4 here. I've got square root x minus 4 under the square root, and then a -1 on the outside. Who can just raise your hand and tell me, like, where would you start that graph? What would be the point? Yeah. 4 and -1. Yep. Just opposite of what it looks like, and copy the one on the outside. With the x is the x-coordinate outside the operation. This is a square root. That's going to be your y. All right, so I'm going to go over 4 and down 1, and we're just going to draw that little sideways U shape. Should point to the right, top half of the sideways U. Domain, 4 to infinity, and range, -1 to infinity. Oh, I'm not on the screen. Fail. Where would I start number 5? What point? I've got square root x plus 2 and then -5 on the outside. Where would you start that one? Somebody just said it. Close. It would be +2 or -2. Yeah, -2. Whatever's inside with the x, do the opposite of what it looks like. It's where it sets it equal to 0. That's where it's going to start. So it's -2. Outside, just copy it, -5. So -2, -5. And then just top half of that sideways U shape. And domain here, -2 to infinity. Range, -5 to infinity. Okay, now, just be real careful. These last two got a little negative symbol in front of these. So this was, you're going to find that starting point in the exact same way, but this general shape here is going to be the bottom half of that sideways U, because when we take our square root, we're just going to multiply everything by -1, so that gives you like the bottom half of that sideways U. So it's just going to look a little different than the ones we just grabbed. Everything else would work exactly the same. So like opposite copy, this would be -3, +1. So I'm going to go 3 to the left and up 1. And just when I draw it, we just draw kind of bottom half of that sideways parabola. Just the bottom half, that way it's a function. Now, the domain should be identical, -3 to infinity. If you're pointed down, the range is different, right? Because gradually, and I know it looks like it levels there too, but gradually that would go down, down forever. And so if I'm going down forever, the lowest possible y value on my range is actually -infinity. That's what you would want to start your interval with. You would stop touching that graph where you get to the point where we started it, and then there's no more of the graph above there. So then I end my interval with that y coordinate of where you started it, which should be 1. And we're going to do one more, and then we'll do cube roots on the back. Okay, now, opposite copy, this will be +2, +1. And I'm going to make sure, because a little negative out in front, we're going to do the bottom half of that sideways U shape. This should be, domain should just be whatever the x coordinate of your starting point is to infinity, because either way it's going to point to the right forever. The range here, because it goes down, we're going to start that with -infinity, and we're going to stop that with 1. Is anybody having a question? Okay, now, the cube roots are much nicer in terms of the domain and range because they're all the same. They're all the same. So what I have here for you guys on the back, just so you guys can see, these were on that parent function paper we just did, so we don't have to do anything here. But the cube root is an inverse of a cubic function. So this is just so you can see, this is just y = x cubed. Cube root is the inverse of that. And so that's two ways you could look. This is the cube root, just a plane. This has a negative in front of it. Now, both of these, no matter which one you have, actually all three of these, no matter what, have the same domain and range here. All right, so when I do this, like one side of this goes to the left forever, one side goes to the right forever. Same with the other one, it's just flipped over. One side points to the left forever, one side points to the right forever. Every single one of these has the same domain. You'll cover every x value because you can take the cube root of a negative, so you go both directions. Now, kind of similar to the square root, this kind of looks like it levels out. It doesn't, it just goes up very gradually, slowly, but this would point up forever on one side, down forever on the other side. Same thing if you have a negative in front, one side goes up forever, one side goes down forever. So all real numbers for both the domain and range. You'll cover all the way from -infinity to +infinity for both. Okay, now I'm going to do this same thing we did on the other side here. For a diagonal translation of a cube root, it's going to look super similar. I'm just going to write an index of 3 on my cube root. So under the cube root, you'd have x minus h, and outside the cube root, you'd have a k. That would be same as the front. H is going to move your, or what did I just do? K is going to move your graph up or down, just like on the front. H is going to move your graph left or right. And I'm going to jot down for the K, you're just going to copy. And for the H, you want to do the opposite of what it looks like. Now, the difference here, the HK, that is the middle of your cube root. So your general cube root looks like this. The HK is going to be right in the middle where it switches direction. So that's the main difference here. Find it the exact same way, and then we're just going to sketch these. So just going to sketch these. We're just finding the middle of the graph instead of the starting point like the square root. So general cube root, and I think all these first three, these are all just a general cube root. So cube root of a positive number is a positive number, so that's the top half of that sideways U. Cube root of a negative number is negative, so that'll make that bottom half of that flip backwards, and we'll have negative values if we plug in a negative value. You just got to figure out where to switch direction. So for this guy, nothing inside with the x, so 0, no movement left or right. Outside you got a 2, so it'd be 0, 2. And then again, you're not, other than that one point, you're not plotting specific points. I'm just looking for a general shape there. Doesn't have to be perfect. It's like kind of like the top half of the sideways U and then bottom half of the sideways U, but backwards. All right, let's see. Opposite copy, this would be positive 4, positive 3. That'll be the middle. And then just, this is a positive cube root, so just look like that. All you got to do. Where would the middle of this last one be? I've got cube root x minus 3 and then minus 2 on the outside. What would the middle of that be? Don't everyone volunteer at once. What would the middle? 3, negative 2. All right, so over 3, down 2, we'll sketch. Now, the rest of these, all right, those are all plain positive cube roots. The rest of these have a little negative in front of them. A little negative. So I just have to remember, if that's the case, the general shape changes. So the general shape here, you're going to flip like up to the left and forward. I didn't do a good job drawing that, but like a top half of a sideways U going the other way, bottom half of a sideways U. That's going to flip it over if you're working with the cube root. You still find the middle the same way. So just opposite, and then I don't have anything outside the cube root there, so we wouldn't move up or down. So this would just shift the graph 1 unit to the right, and then that top half I'm going to flip backwards, and the bottom half I'm going to flip forwards. That would be a general shape there. If I do the next one, opposite copy, negative 2, negative 3. So left 2, down 3. And because of the negative out in front, I'm going to flip that up to the left and then down forward to the right for my general shape there. And then the last one, opposite copy, this would be negative 3, positive 4. So I'm going to go left 3 and up 4. And again, I've got that negative out in front there. So I'm going to flip it kind of up backwards to the left and then down forwards to the right. So you guys just need to know the general shape, and then make sure you're looking, like, is it a square root or do I see an index and I have a cube root? And if you guys can see them, I do have up on the board on that side by those numbers, I've got those general shapes up there. If you want to look at those up on the board, I'll leave that up there.